Hello everyone. The topic today we have chosen is machine learning to detect malicious URLs. My name is Nikki and my partner is Rag and Alekia. We will first start with a brief introduction, then we will talk about current default methods to detect malicious URLs, as well as the flaws. Then we will have a quick overview of machine learning and how it works. We will go over our data collection and our approach to using machine learning to detect malicious URLs. Then we will show our results and talk about any future applications. In today's society, the internet is a part of our everyday lives. As the usage of the internet increases, the amount of malware attacks happening each day is becoming more and more prevalent. Kaspersky's lab reports that over 3 billion malware attacks were detected in 2013. Popular types of attacks using malicious URLs include drive-by downloads, phishing and social engineering attacks, as well as spam. The current default method for detecting malicious URL is through the use of blacklists. Blacklist databases are where malicious URLs are stored. The browser compares the URL with the blacklist database. If it is in the database, the browser will detect that it is malicious and block the URL. The picture below shows the browsers on Windows and Android. Malicious URLs were opened on these browsers to see how many of each of them were blocked. Internet Explorer on Windows performed the best by blocking 41% of the malicious URLs, with the rest being far worse. The amount of false negatives were oftentimes many times higher than the correct result. The false negatives are when the malicious URLs were considered good and were not blocked by the browser. The reason why the browsers perform poorly is due to the flaws of using just blacklists. New malicious URLs are popping up every day. This makes it very difficult to maintain and update the blacklist. Attackers can also modify the URLs using obfuscation. This includes obfuscating the host with an IP, obfuscating the host with another domain, obfuscating the host with large host names, and also misspelling. By modifying these URLs, it makes it hard to identify which ones are actually malicious so that it could be added into the blacklist.
So blacklist method has a lot of flaws in detecting malicious URLs. So we come up with machine learning for detecting the malicious URLs, which is an improvement over the blacklist method. So what exactly is machine learning? So machine learning algorithms help a computer to perform tasks without human interactions. So basically you just train a machine with inputs, and then after enough training data set has been provided, it can predict the results on its own. Now there are several different types of machine learning algorithms. There's supervised machine learning, unsupervised machine learning, and semi-supervised machine learning. Here we're going to be using supervised machine learning. So we're going to be feeding inputs along with some labels saying whether a URL is good or bad. And based on the information that it collects, the machine is going to make a prediction whether the URL is malicious or it is benign. As mentioned above, we are going to be using supervised learning for this model. So what supervised model does is that it's going to take inputs as URLs, and then it's going to read the label for the URL, whether it is good or bad. Then it is going to analyze each URL for its features and studies what combination of features leads it to becoming classified as good or bad. So that's what makes up the training data set, where it learns to differentiate between the different classifications of URL, which in our case is good or bad. Once the training data set is complete, the model can then classify the inputs on its own without any kind of human interference. So once After that, when you keep feeding it more URLs, it's going to classify it as either good or bad. To train this model, we're going to need a huge training dataset. We obtain our training dataset from a website called Kaggle. There is a link for this database in the references. This database had almost 420,000 different URLs which were classified as either good or bad. So the model is going to analyze these URLs to find out what contents a URL needs to have in order to be classified as good or bad. We split this data into 80% training set and 20% testing set. So the model is going to analyze 80% of the data for its training, and then it's going to predict the results for the remaining 20% of the data.
Performance of many machine learning approaches depends on the kind and quality of data we use to train the model. Noisy data and missing values in the dataset can lead to poor prediction or classification. Hence, in order to build a model, we need to make sure the data is clean and processed properly. The data set which we have chosen for our project doesn't contain any missing or noisy values. And the next step is to analyze the values in the dataset. Our dataset contains URLs which we need to analyze and has to identify the features of each URL. Manually analyzing millions of URLs is not possible. So we need something that automatically crawls through each URL and extracts its features. There is a concept called tokenization in machine learning which makes the feature extraction easy. Each segment in the URL which is separated by special characters are considered as words which are nothing but features. Based on these words, a dictionary is constructed which is called as a feature set. This feature set contains features along with with the count of the features in each URL. We used 80% of the obtained feature set as an input to the model and 20% to test the model. We used logistic regression algorithm to build the model. This model is trained in a way that predicts whether an URL is malicious or benign by just comparing the features of the URL with the features of URL in the dataset. If there is a match, then the model outputs the associated label in the dataset. The model performed well with an accuracy of 96%, which is acceptable. And this is the accuracy of the URLs that we used to test the model. To build our application, we used Python, and the slide shows it's just a part of our script. The first line of the code shows how we partition the data into training and test sets, and the URLs we provided to predict whether the URLs are malicious or benign. And it also shows how these URLs how the features are extracted from these URLs, and made a prediction to predict the good or bad URLs. And down the slide it shows the output of our script. It says the Facebook and Wikipedia are good URLs and the remaining two are bad URLs.
So this algorithm can basically be applied to any browser as an add-on. So whenever the user opens a website, and if the URL is malicious, then this algorithm will provide the user with some kind of warning which lets them know that this website is not safe to visit, or also like do not click on this URL. So as of now, this is restricted to only the web browsers opened on computers. So if in the future it might be turned into a mobile application, which when downloaded will be opened anytime the phone browser is open, and it will pretty much do the same thing but on a phone. So these are our references. Most of them are papers that helped us to come up with a better concept about the ideas that we were working with. And there is the link to our training data set, which contained all of the URLs. That's the kaggle.com. Thank you. If you have any questions, please feel free to email us.